Bismillah ar-Rahman Rahim. My name is Shahid Mehmood Akhtar and I am lecturer in chemistry at Government Degree Boys College, Baldia Town, Sector 4E, Karachi. Today I am delivering a lecture from first year chemistry, that is HSSC Part 1 Chemistry, and my topic is balancing of redox equations by ion electron method. So let me start the lecture. Let us discuss the rules for balancing by ion electron method. Here are 6 rules by following which we would be able to balance a redox equation. Going through these rules. So rule number 1 is transfer the given molecular equation into ionic equation. If our given equation is already in ionic form, then this step is not necessary to do. Rule number 2, splitting the equation into two partial equations. Coming to rule number 3, balancing the atoms other than oxygen and hydrogen. Then balancing oxygen and then the hydrogen atoms. So for this purpose, we need to know that the medium of oxygen equation. If the medium of our equation is acidic or neutral, then oxygen must be balanced by putting water molecules, and on the other hand, hydrogen must be balanced by putting H plus ions. And if our medium is basic, then oxygen can be balanced by putting double the amount of hydroxyl ion that is required, and hydrogen on the other hand can be balanced by putting water molecules. In both the cases, whether in acidic medium, neutral medium, or in basic medium, the charge must be balanced by putting electrons. Rule number 5, charge balancing by adding electrons. This is done in step number 5. And step number 6, which is probably the last step, equating the number of electrons in both the equations by multiplying them with suitable integers, then add these two partial equations to get our resultant equation, which must be a balanced equation. So let's try an equation of acidic medium first and then the basic medium onward. So acidic medium equation. The question can come like this, that balance the following equation by ion electron method. This is a redox equation which is given to you. Dichromate radical plus H plus ion plus iodine to produce chromium plus 3 ion, IO3 minus ion or radical plus water molecule. Step number 1, transfer the given molecular equation into ionic equation. We need to omit the given H plus ion and the given water molecule from our equation, because in H plus ion or in hydroxyl group or in water molecule, the oxidation state of neither oxygen nor hydrogen is changed. That's why we omit the given H plus ion, water molecule, or similarly the hydroxyl groups if it is present in your equation for acidic or basic medium. So we have omitted H plus ion here from the reactant hand side, and we have omitted water molecule here from the product hand side. So this is the equation which was already given in the form of ions. That is the ionic equation. Here comes our equation in the ionic form. Coming to step number 2, that is splitting the equation into two partial equations. Now we know that this chromium plus 3 is formed from this dichromate radical. So we made first equation dichromate radical into chromium ions, and this IO3 minus, that is iodate radical, comes from iodine. So we have made a second partial equation, that is iodine has been changed into iodate radical. Step number 3, balancing atoms other than oxygen and hydrogen atoms. So here in the first equation, we have chromium atom other than oxygen and hydrogen. Here in the reactant hand side, we have two chromium atoms, but in the product hand side, we have only one chromium ion. So we'll be putting two here like this in order to balance the chromium atom. In a very similar manner, in the equation number 2, here we have two iodine atoms, but on the product hand side, we have only one iodine atom. So if I put 2 here, then this equation will be like this: two iodine atoms, and here on the product hand side, we have two iodine atoms as well. So in this way, we have balanced chromium here and iodine here, which are the atoms other than oxygen and hydrogen atoms. Coming to the next step, balancing oxygen and then hydrogen atoms. We have 4 oxygen atoms here in equation number 1 on the product hand side. So we need to add 4 water molecules on the reactant hand side. So our equation will become like this. If I add 4 hydroxyl groups, so in equation number 1, here we have 7 oxygen atoms on reactant hand side, but we have no oxygen atom here on the product hand side. So I need to add 7 water molecules here on the product hand side in this first equation. And similarly, in the second equation, here we don't have any oxygen atoms in the reactant hand side, but we have 2 3s are 6 oxygen atoms here in the product hand side. So I need to add here 6 water molecules on the reactant hand side. So I will do this. Seven water molecules on product hand side, and in order to compensate the hydrogen atoms here, we have 7 2s of 14 hydrogen atoms on product hand side. That's why I have added 14 H plus ion here on the reactant hand side in this first equation. Now in the first equation, we have 7 oxygen atoms here in reactant hand side, 7 oxygen atoms in the product hand side, and similarly 14 hydrogen atoms on the product hand side and 14 hydrogens on reactant hand side as well. Coming to the second equation, we have added 6 water molecules in order to balance the oxygen atoms like this. And in order to balance the hydrogen atoms in this equation, 6 2s are 12. So we have added 12 H plus ions on the product hand side in order to balance the hydrogen atoms. Now these two equations are balanced in terms of material. Now coming to step number 5, which is charge balancing. And this step is done by adding some suitable number of electrons on either side of the equation so that the overall charge of reactant hand side must be equal to the overall charge of the product hand side in any equation. So first of all, we need to calculate the overall charge here of equation number 1. 14 positive charges plus 2 negative charges. It makes a net sum of plus 12. Similarly, on product hand side, we have 2 3s are 6 plus charges, and water molecule is a neutral molecule. So plus 6 is the overall charge of the product hand side. Similarly, in equation number 2, iodine is a neutral molecule plus water is also a neutral molecule. So overall charge of reactant hand side in the second equation is 0. And on the product hand side, plus 12 due to 12 hydrogen ions and minus 2 makes it plus 10. So coming to equation number 1, this plus 12 can be made equal to plus 6 by adding 6 electrons on the reactant hand side here. So I have added 6 electrons on the reactant hand side in equation number 1 like this. And coming to equation number 2, this plus 10 can be made equal to 0 by adding 10 electrons here in equation number 2. So that's why I have added 10 electrons on the right hand side of the second equation or the product hand side, so that the net sum must be equal to 0. So in this way, we have balanced the charge of both the equations on both the sides. The last step is equating the number of electrons in both equations so that we can add the two equations in order to get the net or resultant equation. For that purpose, our number of electrons must be balanced. An easier method is that one must take the LCM of these added electrons. Like for example, the LCM of 6 and 10 is 30. So we need to make 30 electrons in both the equations. So 6 can be made 30 by multiplying this equation by 5. and 10 can be made 30 by multiplying this second equation by 3. So multiply equation number 1 by 5 and equation number 2 by 3 and then add both the equations. So I'm multiplying this equation by 5 and I must be multiplying second equation by 3. So here it comes, and then we will add these two equations in order to get the net equation. 5 dichromate radicals plus 3 iodine molecules plus 70 hydrogen ions. Here we have plus 36 hydrogen ions. So here on reactant hand side will be having plus 34 H plus ions. These 30 electrons will cancel these 30 electrons on the reactant and product hand side. Here on the product hand side we have 10 chromium ions plus 3, 10 chromium ions. We have 6 iodate radical and we have altogether 35 minus 18, that is 17 water molecules, and this is our balanced equation. Dear student, here I have wrongly written 5, but it is actually 3. Now I have edited it. Now this is our balanced equation of acidic medium. Coming to the basic medium equation. This is another equation for basic medium, and the question is like, balance the following equation by ion electron method. Sometimes it is written in the bracket also that the equation belongs to basic or acidic medium, whatever is given. This equation is a basic medium equation which is given. Here, in order to start from the first step, which is transfer the given molecular equation into ionic equation, we need to break this molecule, that is the ionic compound, into its ion. So when I break this chromium hydroxide into ionic form, I get chromium plus 3 from this base, that is chromium hydroxide, sulfate as it is, then chromate radical as it is, and sulfite ion as it is. So here is our ionic equation prepared, which we are balancing now. Step number 2, splitting the equation into two partial equations. Chromium plus 3 into chromate radical here. Similarly, sulfate radical into sulfite radical. Here it is in the second equation. As you know, students, that this is the equation with gain of oxygen. So this is oxidation half reaction, and the second equation results into the formation of sulfite from sulfate, that is loss of oxygen, and you know that loss of oxygen is reduction process. Step number 3, balancing atoms other than oxygen and hydrogen atoms. Here we have one chromium atom on reactant hand side and one chromium atom on the product hand side as well. So it is balanced. We have made no change in the first equation. In the second equation, one sulfur on left hand side, the reactant hand side, and one sulfur on the right hand side or the product hand side. So we need not to add any integer. So this is also balanced in terms of sulfur. So these are the two equations with no change in balancing atoms other than oxygen and hydrogen atoms. Coming to the next step, which is balancing of oxygen and then hydrogen atoms. Here I need to tell you that add double amount of hydroxyl groups or hydroxyl ions than the required number. So this will make us easy for balancing oxygen and hydrogen atoms. As I have told you earlier during the rules that for basic medium equation, we need to balance oxygen atoms by putting the hydroxyl groups, and we need to balance hydrogen atoms by putting the water molecules. So let's see, we have 4 oxygen atoms on product hand side, and we need to balance here the oxygen atoms on the reactant hand side in equation number 1. So we need to add not 4 but double amount, that is 8 H plus 8 hydroxyl groups on the reactant hand side here. Let me show you. Here I have added 8 hydroxyl ions on the left hand side or the reactant hand side. Now 8 hydrogen atoms must be balanced by putting 4 water molecules. So 4 twos are 8 hydrogen atoms. Here we have 8 hydrogen atoms and 4 oxygen atoms plus these 4 oxygen atoms will automatically balance here 8 oxygen atoms. Similarly, in the second equation, we have 4 oxygen atoms on reactant hand side, but we have 3 oxygen atoms on product hand side. So I need to add not 1 but 2 hydroxyl groups on the product hand side here. So I made it 2 hydroxyl groups, and in order to balance the hydrogen atoms, we have 2 hydrogen atoms, so I need to add 1 water molecule that contains 2 hydrogen atoms. So 2 hydrogen atoms, altogether 4 plus 1, 5 oxygen atoms on reactant hand side. Here we have 5 oxygen, 3 plus 2, and 2 oxygen atoms. Now these two equations are balanced in terms of atoms other than oxygen as well as in terms of oxygen and hydrogen atoms. The next step is charge balancing. So we must calculate the net charge of reactant hand side and the product hand side of the first equation. Here we have plus 3 and minus 8 makes minus 5. On the product hand side, we have minus 2 on the chromate radical, but we don't have any charge on the water molecule. So net sum is minus 2. In the second equation, similarly, sulfate is minus 2, no charge on oxygen. So net charge on reactant hand side is minus 2, and minus 2 and minus 2 makes minus 4 charge on product hand side of second equation. So this minus 5 and minus 2 can be balanced by adding 3 electrons here on product hand side or right hand side of equation number 1. Similarly, this minus 4 can be equalized to minus 2 by adding 2 electrons here on reactant hand side of equation number 2. So I have done this charge balancing. Add 3 electrons on right hand side of equation number 1 and add 2 electrons on left hand side of equation number 2. So this is done here. 3 electrons on right hand side of equation number 1 and 2 electrons on left hand side of equation number 2. Coming to the last step, equating the number of electrons in both equations. So this 3 and 2, LCM is 6. So we will be making both the electrons 6. So this can be done by multiplying this first equation by 2, equation number 1 by 2, and the second equation by multiplying it by 3. So equating number of electrons in both equations, multiply equation number 1 by 2 and equation number 2 by 3 and then add them in order to get the net equation. So this is done. Multiplying the first equation by 2, here we have this equation with 6 electrons, and if I multiply the second equation by 3, then we will be having 6 electrons in equation number 2 as well. So these are the two equations after multiplying by their respective number of integers. So I will be adding these two equations, 2 chromium ions plus 3 sulfate radicals plus altogether these 6 hydroxyl ions will be eliminated from 16. So net sum of 10 hydroxyl groups here. Similarly, on the product hand side, we have 2 chromate radical here, 3 sulfide radical, and after eliminating 3 water molecules from these 8 water molecules, we have 5 water molecules on the product hand side. So this is our balanced equation in which these 6 electrons are cancelled by these 6 electrons in the two equations. So this is the end of the lecture, and hopefully you would be able to balance the redox equation, whether if it is from acidic medium or basic medium. Thank you and Allah Hafiz.